Right. So just to remind what we have last time. So we have been talking about differentiation now for a few weeks, and we studied a few rules that applies for the differentiation. And this particular problem right here is based on all the knowledge that you had previously. And when you start differentiating a problem like this, the first thing is you need to make sure that there are two functions, cos 6 and 4x squared, and there is a division, right? So which means you need to apply this quotient rule, and the quotient rule is, so if you need to find the differentiation, first what you need to do is you have to write this function right here, 4x squared, and then differentiate the cos 6 function. And you learned last time that once you differentiate cos 6, the answer will be minus sin x, right? So go back to your notes. I don't know whether it's here. It means yes. Right here you can see that differentiation of cos 6 is minus sin x. So that's first part, and then minus. Then you keep the function cos 6 and then differentiate the other one, 4x squared. Now once you differentiate 4x squared, 4 will be right here, and then differentiate x squared will give you 2 times x. So this will be basically 4 times 2 times x, which will be 8x, and divided by 4x squared. And the answer will be minus 4x squared sin x minus 8x cos 6 divided by 16x to the power 4. And I guess some of you have this answer, and there is a difference answer that is just a simplification of the same answer. So what you can do is you can divide the whole expression by 4x, which means then you will have x sin x minus 2 cos 6 and then divided by 4 times x to the power 3. So this is, I guess, the other answer that all of you have. So this is what happens when you simplify it, right? Right. Now let's see for today's class. So let's look at one of the applications that we can use this knowledge that you have right now. So I'm going to give you, remember that this class is all about solving some examples and problems, right? So I'm going to go through another problem. This is directly actually related to the physics. This is about the motion of a particle. So here is the question. A particle moves along a coordinate axis in such a way that its position and time is given by this equation S of t equal to sine t minus t. So let me write it in the next line so that 2 sine t minus t. And the question is, for 0 less than t less than or equal to 5, sorry, this particular equation is valid in this range. So that's the idea. And the question is, at what time is the particle is at rest? So this is the question. Now you can see that this is a physics question that you have to solve, and what you need to do is apply the differentiation techniques that you have used up to now to solve this problem. And this is a classic example how you use differentiation in physics, basically. And so you are given the function of position. So if I give you a few minutes, can you try this? So what you need to find is, you are given an equation how the position is changed with the time. What you need to find is at what time the particle is at rest. Okay? You probably have done these kind of problems in your first within the first set of lectures in the physics lecture series as well. Anybody have any idea how to solve this? Right, so here the idea is, so what you want to determine is when the particle is at rest, right? But what you are given is actually the function of position which will change with time, 2 times sine t minus t. So this is the equation, 2 times sine t minus t. And if the particle is at rest, so what should happen to its velocity? Anybody knows the answer for that? What should happen to its velocity?
Zero.
Zero, right? Yeah, thank you. So the velocity should be zero. Now that is the information that we know from physics, right? If the particle is at rest, velocity, again it will be a function of time, should be zero. So we need to find at what time the velocity is zero. But we are given the function of position. Now what we know from the differentiation is that what we know from physics is that the velocity is rate of change of position over the time, right? And from the differentiation, we know that once you know the position, how position change with the time, if you differentiate the rate of change of position, that will give us the velocity, which means the first step will be to get an equation for the velocity. So that will be basically the differentiation of this position function, s dash t. Now this is where you need the knowledge about the differentiation. Right? That is, s dash t means you need to differentiate this function right here. So 2 is a constant, and we know that differentiation of sine t will be equal to cos of t, and then minus, once you differentiate t itself, the answer will be 1. So this will be the equation for the velocity, 2 times cosine of t minus 1. Right? And if the now we have the function of the velocity. Now if the velocity is equal to 0, so that means Vt should be equal to 0 for particle to be at rest. So that means our velocity equation is 2 times cosine t minus 1 equal to 0, and this should be 0. And another thing that we know is this function is valid only between 0 and 2π, right? So that is given. So velocity for between 0 and 2π. Now what we need to find is at what points or at what t values this function becomes 0, right? So what you can do is you can solve this now. So I can see one of you have got the answer as cos t equal half. That is the value of cosine of t, right? Now we need to find the value of t based on this equation where you get this particular particle's velocity equal to 0. Now if you go and look at the trigonometric values in a table, you will realize that this half is basically equal to 60 degrees. Half means in terms of cosines that will be 5/3. And so which means when the value of t is equal to 5/3, the velocity of the particle will be equal to 0. And not only this value, if you go back and check these trigonometric tables, the cos t equal half will be valid also for cosine of 5 times 5/3. Check this and you will realize it. Right? So that means there are two places at t equal 5/3 and t equal 5 times 5/3 where you get the velocity of the particle equal to 0, right? So this is an application of differentiation rules in physics. And if anything is not clear, feel free to ask at any time. You can unmute your microphone and talk at any time. Or if not, you can also post your question in the chat window. Right, so last time, remember, we actually did two functions, two trigonometric functions, differentiation of cosine and sine. And let me go through the other equations, and these are actually direct equations that you need to remember, because I am not going to go through the proofs, and you don't need to know the proof for physics as well. Right, so this is about so I'll quickly write through these equations, derivatives of other trigonometric functions. So one function will be tan x. So if I let me use the same notation, yeah, I use. So if you differentiate tan function, the answer will be something called sec squared x. So I assume that you know some trigonometry and you know what sec means, right? Sec x means. Basically, sec x means 1 over cosine of x, right? And there is another term called cosec x. So that means 1 over sine x. And there is another trigonometric function called cot x. That is basically 1 over tan x. So you may know about sine, cosine, and tan, and reciprocals of those three functions also have separate trigonometric functions: cot x, cosec x, and sec x, right? So all you need to do is just remember that they are reciprocals. And similarly, for these three trigonometric functions, now I wrote there. If you try to find the differentiation of cot x, this will be minus cosec squared x. The other one will be sec x minus, not minus actually, don't have minus. Sec x tan x. And these things you have to remember, right? Normally what happens is when you use these equations very frequently, these will be automatically remembered. Cosec x, cot x. So these are the trigonometric differentiations that if needed you can directly use at any time. And of course there are ways that I can prove these, but for your scope you don't need this. You just need to use the functions. Maybe in your mathematics class for bioscience students, so that these things maybe you will prove these things in that class, right? For us, we don't need that, so I will skip the proof part. Right now, based on these equations, let me have a question for you. A very simple example. Let me take if x equal cosec x plus x tan x. Can you find it if dash x? So I will give you a few minutes to try this. And these are basically what I am doing here is just using the things that you have been learning up to now. Right? So try this and see whether you can solve this and find a final answer based on the trigonometric functions that we learned up to now.
UPSC आते को मंत्र को गाने चाहिए। Sorry.
Please make sure that you try these problems yourself, right? I can directly solve this, but then you won't learn anything from that. So I already have one answer. How about the others? Because once you post your answers here, then I can specifically look at those answers and see where things go wrong and discuss that particular point, right? So otherwise, I will just go through the answer without knowing that what are the problems you have. Right, so I have two answers. Right, three answers. All three answers are similar. And let's look at what I have here. So you have one function right here, cosec x, and then there is another function here, x times tan x, right? So there is a function, but it also has two expressions right there, x times tan x. So what you know from the knowledge that you have is, once you have two functions added together, you can differentiate those two separately, right? And you can straight away see that the differentiation of cosec x is minus cosec x cot x. So that's fine, right? Plus, there is a thing that you have to understand here. This function right here has two terms, x and tan x. Basically, x is multiplied by tan x, which means there are two functions inside this. There is one function right here, which is x, and then the other one is tan x. So this is basically multiplication of two functions, which means for this particular section, you need to apply the product rule to get the answer, right? So what I can see from your answers is most of you have directly applied just the the differentiation of tan x, and the differentiation of x is missing. Remember that all these rules that we are talking will be combined when you have to solve the problem, right? Now you have, this is like fx, and this function right here is like gx. So this is like multiplication of two functions, x times tan x. So you have to use the product rule that we learned previously, which means when you use the product rule, what you normally do is you keep one function. Let's say you keep x right here, and then you differentiate tan x. That is sec squared x, right? So this is one term, and then plus, and I guess almost all of you have missed this term. The next term is you keep tan x and you differentiate x, right? So you keep tan x and then you differentiate x. That is this function right here. The differentiation of x is equal to 1. Therefore, you just have the tan x term there. Now, make sure that you understand the differentiation of this term right here, x tan x, is this whole expression, because that's a product of two terms or two functions, right? So you need to have this term as well, which is what you are missing in all of your problems. So I guess you can understand it now. So that is minus cosec x cot x plus x sec squared plus tan x, right? So this is the final answer. So make sure that you understand that this term should be there, right? Now this is why we solve problems, because unless you solve problems, you can't catch these little things that are important, right? So feel free to ask if you have any questions regarding this particular equation. So make sure that even though you learn new things, you have to apply all the things together that you have learned before, right? When you do differentiations, right? Let's talk a little bit about, now you know how to how to differentiate most of the functions, right? There are some more that we have to learn, but let's look at the next section, which is about higher order derivatives. We have it here. So higher order derivative means something like this. So let me get an example. Let's say y equals sin x, right? And then you differentiate this. Now we know the answer. We do dy over dx. The differentiation of the sin x will be cosine of x, right? And then if you differentiate this for the second time, so that will be called as a second order derivative. And we have a symbol for that. We normally write it as d. 2 is to symbolize that you are differentiating it for the second time. And then d x squared or x2. That means you differentiate this answer, cosine of x. You know, when you differentiate cosine of x, the answer is minus sin x, right? And then you can go for the third order one. So that is normally written as d3 over y and dx3. So that means you are basically differentiating this term. So you have minus, differentiation of the minus sin x is cosine of x. And if you go for the next order, that will be fourth order. So you are differentiating for the fourth time. Now you have minus, and then the differentiation of cosine x is again minus sin x. So this will again give you sine of x. And you can see you start from sin x, and then again after a few differentiations, you are getting the same answer, right? And so there is a pattern for that, which means even looking at these patterns, you can decide about the higher order derivatives, which means this is something actually extra. You can see the fourth one is becoming sin x, right? Now if you start again the fifth one, then the next one will be cosine x again, and then minus sin x, minus cos x, again sin x. You can see that this goes in a cycle. So which means uh, the next one will be the eighth derivative, And like that, you can go for 12th derivative. Like that, this goes on. The answer will be same for this particular sin x. Same way, you can think about first derivative and the fifth one. All of them will be cosine of x, right? So this is something extra that if you look at a pattern, you can decide actually the higher order derivatives without solving it. Right, so let me just finish this section by having one final example, not the class actually, this particular section. So this is again an application in physics. Again, a particle moves the coordinate axis in such a way that its position at time t is given by s of t equal to minus sine t, right? Something similar to what we had before. So what you need to find is find v phi over 4. Basically, what is the value of the velocity at this particular time, v phi over 4, and a phi over 4. What is the value of the acceleration? And the next question is compare these values and decide whether particle is speeding up or slowing down. Now this is again a good example that how you use the knowledge of differentiation to solve a problem in physics. Right, now to solve this, so there are several things that you need to apply. The first thing is you are given the position function as 2 minus sine of t. Now the first thing that you should understand is if you need to find the velocity from this function, you need to differentiate this function first. So that means the velocity is the differentiation of this function. And all you know is the differentiation of 2, it is a constant and that will be 0 because here the 2 is along and there are no other functions, minus, and differentiation of sine t will be cosine of t and the answer will be minus cosine of t. And this is one function that you need, and what you ask is find v at t equal 5 over 4. So which means you need to find cosine of 5/4. Basically, you have to plug the value of t here. So this will give you an answer equal to minus, check this value, cosine 45 degrees, that will be 1 over square root of 2. So this is what we have for the velocity, and you can see it is a minus value. And then let's look at the acceleration, right? Now, when you try to find the acceleration, what we know is acceleration is defined as rate of change of velocity. So that means differentiation of velocity. And you can see again, this is similar to what we talk here about higher order derivatives, right? You first take the derivative one time. When you need to find the acceleration, you have to get the derivative of that particular function again. Now what we know is, we know that Vt is equal to cosine minus cosine of t, and then we have to differentiate it again to get the acceleration. So that will be, so when you differentiate minus cosine of t, the differentiation of cosine of t is minus sine t, and there is already a minus sign right here, so that will cancel out. So your answer will be sine of t, right? That is the acceleration. And if you find the acceleration at t equal 5/4, that will be equal to sine 5/4, and you can look at this value from a table. If you can't remember, the answer will be 1 over square root of 2. And you can clearly see that this value is positive while velocity is negative. Right? So what that means is the velocity and the acceleration are acting in two different directions. Basically, object is accelerated in the direction opposite to the direction that it is traveling, right? So this tells you that basically the particular object is slowing down, not speeding up, because velocity is towards one direction and the acceleration is towards the other direction, right? So I hope this is clear for you. And if not, just go back and look at it. And the same problem is also available in the book. If you want to look at, I will write here that as well. Example 3.47 in calculus volume 1, which has in fact more details than what I have written here. So if anything is not clear, you can go back to the book and look at this now. With my explanations, you should be able to understand it now. Right, so that's the end of that section. And let's go for the other one, which is about actually chain rule. This is called chain rule. Right, and this is another set of rules that you need when you have some complex functions that you have to differentiate. Right now, up to now, we know how to differentiate different types of functions, like when you have a sine function, cosine function, and if you have a function of x or any power of x, you know how to differentiate those. And apart from that, you also know when you have sum of two functions, difference of two functions, products or quotients, those kind of things that you know how to differentiate. But even though you know all of these things, think about a function like this. Let's say you have a function hx which is equal to sine x to the power 3, right? or you have a function which is equal to kx equal 3x squared plus 1 and the square root of that. Now, if you have a function like this, how you can differentiate that? For these kind of functions, actually there is a function inside the function. So which means you cannot directly use the knowledge that you have up to now to differentiate a function like this, because you have x to the power 3 right here, and that function is inside this sine function, right? So that is the problem here. And here you have a square root of this whole function, and inside that you have another function called 3x squared plus 1, and you know how to differentiate this one, but then you have another one outside that. These are called functions of function. Now when you have situations like this, in differentiation there is a rule called differentiation rule that you can use to solve these kind of differentiations. And let me directly write the rule, and then we will directly go and solve some examples, right? The rule is, this is actually called the chain rule, which I have mentioned above. And let me write this probably in a different color. So let f and g are functions and actually these kind of functions are called composite functions, because there is a function inside the function. And then if hx is written in this way, or sometimes this is also written in this way. The idea here is you have function gx inside the function fx, right? So that is the idea. It is something similar to this one right here. So you have function right here, x to the power 3. This is like gx. So if I write it here, this is like gx, and this whole thing is like fgx. So you first have a function, and then you have a function f, and inside that you have this function gx. Now in mathematics you normally write these kind of composite functions using these two symbols. You can write it either in this way or that way. It is not that much important for us. And when you have these kind of situations, the differentiation of function h dash x is given as, first you have f dash gx, and then multiply it by g dash. So this is how you differentiate, and this is also called as a chain rule. The idea is, if I directly explain it to you from this example right here, so for example, now you have hx equal sine x to the power 3, right? Now this whole function, if I take this whole thing, that is what we have as f dash gx, right? And gx is this function only. So if I write this, sorry, not f dash, actually this is f, this whole thing is fgx. So that means the whole function f gx is equal to sine x to the powers 3, and the function gx is x to the power 3 only. So this is how you divide it to two sections. Now when you differentiate this, first you differentiate this function right here, f dash gx. So what that means is you just think this particular function as a one unit and differentiate the expression. Now in this particular situation, f dash gx is actually cosine of x to the power 3. So you just think this as one variable or one function, one unit, right? You don't think what is inside that. You have a sine function and then you differentiate just cosine of whatever the function inside that. And after that, you have to differentiate g dash x. G dash x is what you have inside here, x to the power 3. So that will be 3x squared, right? Now, according to this rule right here, then you can write h dash x as a multiplication of these two. So that will be cosine of x to the power 3 and then 3x squared. To make it clear, let me bring this 3x squared to the front and then write it like that. And this is how you differentiate when you have a composite function. And sometimes you write this rule in a different way. So I will write that as well. This is the same thing, right? But from a different notation. If y is a function of u, and u is a function of x, then you can write this as dy over dx equal dy over du times du over dx. Basically, this is the same thing as what you have in the other expression, right? So you will understand it. Right, so now we know the rule, and there is actually a strategy that you can use here. This is also mentioned in the book, but I will write the same thing here so that this will be a little bit easier for you to understand when you solve problems. So make sure that you go and look at the book as well. This is in the book in terms of more details, and the section is 3.6 in the book. So these are the steps that you can follow if something is not clear for you when you apply this chain rule. Right? That is to, so let me write it, to differentiate composite functions such as hx equal to f times gx, First is identify fx and gx. So that is the first thing. Now first you need to identify what is fx and what is gx. And then once you identify those, second part is find f dash x and g dash x. Because once you identify the two functions separately, you should be able to differentiate those two separately. Right. Sorry, not actually. This will be find f dash x and evaluate it at gx to obtain f dash gx. And then the third one is find gx, find g dash x. And then the fourth step is write the final answer h dash x equal f dash gx dot g dash x, right? These are the four steps. I mean, you can, I just wrote it quickly. You can look at the same thing in the book, so I don't need to repeat it. It's the same thing. Right, so let me have some examples here to make it clear how you can use these composite functions. Right. So the example 1, find the derivative, that is actually finding h dash x of the function hx equal 1 over 3x squared plus 1 and to the power 2, right? And you can actually write this, if this is not clear, you can write the same thing by bringing this up. That will be minus power to the minus, power will be minus 2, right? Now how we can find the derivative of this one? Now, as I have mentioned above, the first thing is you need to identify what is gx and what is fx. Now, in this particular situation, you should be able to understand that this is the function which we can call as gx, right? So gx will be 3x squared plus 1, right? So this is the function gx. And which means now you can write gx is right here. So the first thing is you need to find f dash gx, right, according to this these steps. Now, if think it in this way, if you replace this whole thing by x, right? This is an easier way to understand this whole thing by, let's say, x, then this will be x to the power minus 2, right? So you know how to differentiate that. You have to do the same thing again. And I can see there is one answer that someone posted already. So this will be x to the power minus 2. So very similar to something like that. So know that you take minus 2 right here, minus 2x to the power minus 3, right? So that is the answer. You are basically doing the same thing here. So the first thing is you differentiate you need to find f dash gx first. So this is actually so let me write it. If gx is what you have here is minus 2. So this is what you called as fgx. Now, if when you write the f dash gx, take this as one complete unit, right? You don't have to think anything about that. This is like x, and you differentiate that part separately. So which means the answer will be minus, for the f dash gx, the answer will be minus 2. This is like x, let's say it's the large, big x, right? And then there will be a power of minus 3. And then this is multiplied by, this is f dash gx. And we know that what is gx is from here. And we know how to find the g dash x, right? So g dash x will be 6x. So that's g dash x. So the final answer h dash x will be equal to f dash gx times g dash x. So that's the answer, right? H dash gx times g dash x. So that is the fourth step there. So which means f dash gx means this expression right here. So that will be minus 2 3x squared plus 1 to the power minus 3, and the g dash x is just 6x. Now you can solve this. That will be minus 12 times x, 3x squared plus 1 minus 3, right? Now you can see that this seems like this is a bit complicated, but if you look at carefully, all you need to do is first you need to clearly identify what is gx, and then at the first place when you try to find f dash gx, this consider this as one complete unit like a large x, right? And what you know here is what you have is x to the power minus 3 there, right? This is something like that, f dash gx, so that it will be easier for you to think, and you apply the differentiation rules that you know, thinking that this particular function is just one single unit like x, and then you move on to gx function and then differentiate gx, and then you multiply those two together, right? So that's what you would do. Yeah, I can see that some of you have actually solved and posted here, which is good. Right, so let's look at some examples. right? So let's get the same function that we had. Hx equal, so let's take this one, let's find the derivative of hx equals sine 3x. And make sure that when you write it in this way, this is same as sine x to the power 3, right? Which means sine x is repeated 3 times. So that's the idea. Right? Normally when you have sine functions, the first expression, this is how you normally write, but the idea is this. Right? Now first thing is you need to identify what is gx here. Now gx in this particular situation is the function that is inside, that is sine x. So gx is equal to sine x in this particular situation. And then think that as one unit like a big X that you have here. So which means if, so I guess now if I write it this directly, so you can, I assume that you can understand this. When you need to write h dash x, what you need to do is first apply the power rule, because you have sine x, this whole thing to the power 3. So think this as a 1 unit and apply the power rule. So that means 3 times. If I use the same symbol, that will be x to the power 2. But we know that what x means here is sine x, right? So sine x squared. And then you have to have the g dash x. And we know that when gx is sine x, g dash x should be equal to cosine of x. Yes, good. Some of you already solved that, right? 3 times cosine x and sine x squared, or you can write sine squared x, right? This is the answer, right? You don't need to write step by step. Once you know how to do that, you can directly write the answer. So it should be fine. Right, so let me have a question for you. Find the derivative of hx equal cosine of 5x squared. Right? So I will give you some time. Try to find the answer for this one. So I would like all of you post the answers here, because I can see that only some of you are posting regularly and some of you are very silent. So try the answers and post your answer in the chat window. So I will give you a few minutes for that. So identify what is gx, and then everything else will be easy, right? So you just, if it is gx, then you write just cos gx, that will be minus sine gx then, and then you differentiate gx again. So that's how you do it. You will see that when you get used to this, by solving few problems, you can directly write the answers for these expressions. You don't have to worry about like steps or anything like that. You can see that one of you already have the answer. Right, so I can see that you have posted few answers, and sine 5x squared should be minus sine 5x squared and then 10x. Yes, so most of answers seems to be correct. So I will not go through this again and again, but let me give you the answer. So this will be, first you think this as 1 unit. I mean, most of your answers are correct. So in case if you need to know how to do this, think about this whole thing as 1 unit, right? And this is like cosine of x. Then you differentiate it sine of x. So x means here 5x squared. So then that part is done, and then you go inside, which is gx. Here gx will be equal to 5x squared, and you differentiate that. That will be 10x, right? You know how to do that. So you combine the answers. 10x times sine 5x squared. So this is the answer, right? I guess most of you did that. Right, next one is hx. So let's do it in this way rather than going through a lot of things. I will here is another example. Sec, this is sec, right? And these are for you to complete at home. This is one example. Sec 4x squared plus 2x. And then there will be another one. Let me give you a different one. Hx equal 2x plus 1 to the power 5 and 3x minus 2 to the power 7. Right? And try these two functions, try to differentiate these two and find the answers at home. Before we leave, let me just show you another aspect of this same chain rule, which we also call as Leibniz notation. Remember that I had another way of writing the same thing, that is, if y is a function of u and u is a function of x, then you can write dy over dx as dy over du times du over dx, right? And this is important in actually in physics. Most of the time you use this equation. This is like a theorem, and it is not hard to understand, right? So you have same terms here, du, and then dy is here, dx is here. And one example of using these, this is also called like Leibniz notation, but what is important is how to use that. Let's say you have a function like this, y equal x divided by 3x plus 2 and to the power 5. And like in the chain rule, now I am going to decide which function is u and then go after that. So I am going to define this function right inside x over 3x plus 2 as the u function, right? And then I can write this expression as y equal u to the power 5, right? Because I'm just replacing this function right here. Right, so there is a short disturbance to the lecture. So let me just go through this particular part only. Right, so I guess we are back here. And once you have y equal u to the power 5, now you can find these two terms from here. That is, y equal u to the power 5, you can find dy over du. That is easy, right? That will be 5 u to the power 4. And then we know from here that u is equal to x over 3x plus 2. And you can find du over dx from this expression. You just need to apply the quotient rule that we talked before. And once you know these two, dy over du and du over dx, you can directly find dy over dx, because that will be equal to dy over du, which is this function right here, times du over dx, right? So once you know this expression and that expression, you can directly find the answer for dy over dx. And this is another way of using the chain rule. Right? And try this problem as well. Okay, so let's talk again about this this last section next time as well. But the idea is, so if you find the answer for du over dx, what you will get is 2. So check this answer, 3x plus 2 to the power squared. Right? Now dy over du is 5u to the power 4 times, and du over dx is 2 over 3x plus 2 squared. Now you can plug the value of u here. U is x over 3x plus 2 and the fourth power of this whole thing, and then 2 over 3x plus 2 squared. Right, so this is the whole thing. And then you can simplify these terms. So you have 10x to the power 4. Right here you have 3x plus 2 to the power 6. And this is another way of doing the same chain rule, right? So you just, I guess you can understand this while you decide which function is u, and then you write the u as a function of x, and then you can write the y as a function of u, and then you differentiate this term and this term separately and substitute to the equation. Directly it will give you dy over dx, right? So that's what we did here. Right, so I'm going to stop the lecture for today. It's close to 9 now. So make sure that you check this last section, this one right here, check the answer, which I did here, and also these two examples. So try these two examples, right? So we will check these at the beginning, and once we are done, we will try to finish the final section within next 2 days, which is about how to derive inverse functions and then how to get the derivative of exponentials, right? So those are the two things that are remaining for us to finish in this particular section, and then we will talk a little bit about applications of the derivatives, and then we'll move on to the integrations, because you need to know how to do integrations as well. And after that, if time permits, we can go for the differential equations, how to solve differential equations, and these partial differentiations which you have asked. And this will depend on how much time we have towards the end of the semester. So let's see how it goes. For the now, I will stop from here. So once again, make sure that you solve these problems yourself, right? Other than you will not understand. Anybody have any questions up to here? Right, so if not, let me stop from here. So I will let you know the next date, maybe towards the end of this week or weekend, or maybe early next week. So I will let you know about the time later, right? Right, thank you.
Thank you, sir.
Yeah.
Thank you, sir.